Good morning, everybody. This is James Martin from Q-SYS in the UK, and welcome. Thank you very much for joining me on this very exciting Q-SYS Architect webinar. Okay, so of course we're all here because we want to learn about Q-SYS, and Q-SYS Architect is going to take us through everything that we need to know about Q-SYS for designing systems. Okay, before we crack on, let me just appear on your screen. Hello, everybody. My name is James, and in architect training, what we're going to be doing is looking at the whole Q-SYS platform. We're going to be going through, audio, video, control, and how that all really sits in a single platform in the world of Q-SYS. And then we're going to be doing lots of system designs to, understand the best way to design different systems using different parts of the Q-SYS platform. And by the end of the Q-SYS Architect training, you will be very good at designing all sorts of different Q-SYS systems, from very small systems to very large systems. Before we crack on, please do use the Q&A section. So we really welcome any questions you have. Even if you have a question that's a little bit off topic, that's fine. I might come back to it later. Or if you want me to go a little bit deeper into a particular technical aspect of Q-SYS, that's completely fine as well. Anything you want to ask, put it in the Q&A and I will do my best to answer all of your questions. Okay, so let's have a look at what we're going to be talking about in this morning's webinar. We're going to start off with an introduction to the whole Q-SYS platform. So if you're brand new to Q-SYS, if you don't really know anything about it, that's fine. You're in the right place. Okay, we are going to have a look at it here on a high level and get an overview as to what Q-SYS is all about. But then we're going to learn more about it through the lens of these different design exercises. Okay, so we're going to start off with a meeting room. We're going to have a look at a typical meeting room. And what do we need there? Well, we need to have a look at the audio. We need to have a look at the video and also USB bridging in a meeting room, which is a really key Q-SYS technology that will tie a lot of these different applications together. And once we've done that, we're then going to actually scale up. And one of the key themes we'll see in this presentation is that Q-SYS scales up in a really nice, elegant way. When you move from doing a small system to a much bigger system, you don't typically have to relearn, all of the approaches that you're taking to system design. You're just going to consider a few different things, but essentially you're going to be approaching it in the same way. And that's what we're going to learn about here. We're going to look at larger spaces, more complex spaces, what we call high impact spaces, looking at where we might need to upgrade our processing, look at control, network video distribution, and all those things that typically come into play in a more high impact space. Okay, then we're going to go bigger still. We're going to look at doing a centralized deployment using larger Q-SYS processors, and talking about what are the pros and cons of having fully centralized processing versus distributed processing, where we might have lots of different processors all working together. And then towards the end, we just got a little section on topics that you really need to know about for any kind of system. So, cloud-based monitoring management, how that really works, redundancy for when you have really mission critical applications, AV networking, a little bit about licensing of different features where we do a lot in Q-SYS with software. And then towards the end, a little look at the Core 5200, which is the largest Q-SYS processor for the largest systems. And then there is an exam. Okay, so don't worry about the exam. It's very straightforward. You're going to get 10 questions. You've got to get 8 of them right. And then you're going to be Q-SYS Architect certified. You can put a little badge in your email signature, make all of your friends jealous. All right, so we're going to start off with a look at the whole Q-SYS platform. And here I have a little map, okay? This is a sort of conceptual map of the whole Q-SYS platform, talking about the different aspects of hardware and software that really build Q-SYS, okay? And this brings me on to one of the key differences that Q-SYS has over many other types of AV product. So traditionally in the world of AV, typically what we're talking about is lots of different bits of hardware that a system integrator is going to need to combine together to build a system for their customer. Typically that's what we're talking about, right? Now, Historically, it doesn't really matter if these are from lots of different manufacturers or they're even all from the same manufacturer. They are typically going to be different product lines for audio processing, for things like amplifiers, and then moving away from that, you're going to have completely different product lines for video, for control processing as well. And whether, like I said, whether they're different manufacturers or the same manufacturer, they're going to be using sort of standard interconnects, standard sort of things, maybe like Dante or certain control APIs, but it is going to be down to the integrator to really make this work as a seamless system. And you've got lots of disparate hardware and software in those types of installations. Now with Q-SYS, the real key difference is just that instead of all those different systems, we have one system. So really what Q-SYS is it's a software-based foundation for audio, video, and control, like it says right there. Okay, so this is really the only system out there that does audio, does video, does control, all under one roof and all managed in a more centralized, standardized way. Okay, so instead of us just putting together a load of boxes and trying to make it all work, what we're going to be doing is using Q-SYS products. We're also going to be using third-party devices where we need to do that. And we're going to be thinking, okay, do I need cameras? Do I need control devices? Do I need amplifiers? Do I need some kind of video distribution? And what we're going to be doing there is adding the right Q-SYS products for that installation. You know, what kind of inputs and outputs to the system do we need, essentially? Okay. Now, the difference here is that all of these, doesn't matter what category of product they are, doesn't matter if they're a camera or an amp or a control device, they're all based on the same software foundation. They all communicate in exactly the same way, and they all work with Q-SYS processors in the same way. And that's what we're going to start taking a look at here, Q-SYS processors. And in this case, it's different to, again, the way the AV industry typically works. We've not got processors for audio and a separate one for video and a separate one for control. All we have are Q-SYS cores, okay? Now, a Q-SYS core is a processor which, like I said, can do all of these things in the one processor in a centralized way in the one environment, okay? So rather than programming lots of different things, you're just dealing with the core and you're making this do everything. It's going to then be reaching out to all of those Q-SYS products that we saw over here and managing them and monitoring them. And because these all communicate in the same way, that's super easy to do. Now, the thing you see here is lots of different Q-SYS cores. There's a big pile of different products here. The key thing to recognize is that these really are all essentially the same thing in terms of what they're capable of, in terms of the jobs that they do, okay? Whether that's audio processing, control, video, they're all the same in that regard. They all have the same IT standard architecture, and we'll talk about that in a minute. They all have the same software on the product itself, the same audio engine, same video engine, same control engine, and they're all configured using exactly the same piece of software, which is called Q-SYS Designer. And in fact, that's really the only software we make, is one thing that does all of these different jobs in one environment. But you can see there's lots of different cores here, okay? So what's that all about? Well, essentially, they only differ in the amount that they can do. So not what jobs they can do, how much they can do, you know, how many inputs and outputs, how much processing, for example. And the other difference they have is that many of these smaller ones in particular have some, you know, specialist inputs and outputs on them, different types of I/O for different kinds of applications. And very quickly, we're going to look at this right now. So down at the lower end, we have the Core 8 Flex and the Core Nano. And these are now essentially the sort of default Q-SYS cores that you might use in any project. Okay, when you start to get into larger projects, we're going to move up from these, but these are very, very capable, and they're actually exactly the same in terms of the processing that they have. You can see here, both of these have 64 channels, inputs and outputs of network I/O. They can do 8 AEC processors. Well, what does that mean? Well, we actually measure, one way you can measure processing performance is by looking at this number, okay? Now, this is because acoustic echo cancellation, that's what that means. That's an audio bit of processing, and it's one of the most complex bits of audio processing that a core is ever going to do. So that means that we can easily slap a number next to that. It's not like some massive number. It's, you know, 8. We can do 8 of those. We know that we can do that. And that means we can compare different cores with each other just by looking at that in terms of their audio processing capability. okay? And these have a limit of 32 Q-SYS peripherals, and that will be any of the other Q-SYS products we're going to talk about, okay? These are also software scalable, so we can actually upgrade these by upgrading the software that runs on them. So quite a lot of processing power here, but also we've got one difference. So they're exactly the same in the processing. They're just different in the local I/O. Okay, so a Core 8 Flex has 8 flex channels. These are a type of audio channel. It can be inputs or outputs. And a Core Nano doesn't have any of that. So a Core Nano is great for those more modern installations where we might be using the network to deliver all of our audio inputs and outputs and all of our control. In that case, do we need any local channels? Probably not. And of course, Core Nano is going to be lower cost as well. But moving up from that, when we get into the more complex spaces, then we might start to think about larger, more powerful Q-SYS cores. So the next step up would be this one, Core 110F, and it's very straightforward. It's about double the processing, roughly. Okay, so you can see we've got 16 AEC processors. We've also got about double the network channel count. The key thing about the Core 110 is you've got loads of analog audio input and output. So 24 channels of input and output combined, okay, which is obviously quite a bit more than the 8 that you get with the Core 8 Flex. Then you go up from there, and now we start to look at products that actually look a lot like Dell servers. These just look like a straight up IT product, and that's because they are. Okay, so at this point, we're talking about having a core maybe in some kind of centralized location. It's just doing processing for a really large system. We're not going to be connecting lots of local I/O. It might be in a comms cabinet or a server room somewhere. And at this point, we're talking about lots of processing power. So this has got double the network audio channels again. This has got 4 times the number of echo cancellation. So that gives you an idea of the general audio capability at this point. And also, these are also software scalable, so this can actually be upgraded further. And then for the very biggest systems, you know, things like football stadium, a whole hotel, or a great big centralized corporate AV deployment, you've got the Core 5200, and that's again double the network I/O and 160 AEC processors, which is a pretty big number. Okay, now this is kind of interesting. These server products, they don't even say Q-SYS on the front, right? They just say Dell. They have got hexagons on the front. We've got hexagons in our logo. That's more of a coincidence than anything else. Why have we got these Dell servers that don't say Q-SYS on them? Well, essentially, all of these Q-SYS cores, doesn't matter if it's the Dell ones or the smaller ones, they are all essentially just IT products. And this is very different to the way that the rest of the AV industry works. Other kind of AV products, audio processors, for example, if you open one of them up, you are going to find a DSP chip designed to process audio on a hardware level. It's designed to take in audio samples and do maths on them, okay? And that's great, but that is going to be very limited in the amount of power it can have and also the flexibility of that. But it's obviously going to be a bit simpler for that manufacturer to deploy because they've just got a chip that does what they want on some level. Now, what we've done is we've taken Intel processors and put that into all of our processors, okay? Now, that means that we can do anything we want, essentially. Just like on your PC, you know, you don't get a PC that just does one job. It's got a general purpose CPU, and you can do whatever you want on it as long as you can get the software on there to do that. And it's the same thing with Q-SYS. So really high power Intel processors. It's running a Linux operating system. It's got IEEE network drivers, right? At this point, it's just really a IT product. But then we have the Q-SYS software layer. And this is really what Q-SYS is. When people talk about, you know, what Q-SYS actually is, really the magic is in this software layer here that's doing all the audio processing, all the control, all the video, all the management, all the monitoring, all in software. Okay, now one of the benefits to this is the amount of power it gives us. So these kind of chips move much quicker than a lot of the sort of, you know, very specific purpose chips that you find out there. But also it means that we can be very, very flexible. Let's talk about power first, okay? Because when we have these Intel processors, it does mean that the amount of processing headroom, the amount of processing power that you have with Q-SYS is genuinely unmatched compared to other products, you know, similar products out there. Now, it's kind of hard to quantify this, but we had a go, okay? So we took this signal chain. This is an audio signal chain. Of course, very straightforward. EQ, compressor, limiter, crossover, mixer. You could run that on any audio product, right? So we just copied and pasted that. We said, how many times can we run that audio path before the processor runs out of juice? And it turns out that you can do that 146 times on a Core 110. Now, what does that mean? Well, a Core 110 is kind of in the middle of the Core, lineup, right? It was a sort of second tier up in terms of processing power. But if you compare that to a product that's similarly positioned in terms of, processing capability, it turns out that actually it can do 7 times more instances of that signal path than that other product. And that's the Core 110, okay? If we start to move up, a Core 610, that's got 12 times more power than a product that's similarly positioned. And then you look at the Core 5200 and it's not even fair. Okay, so that's processing power. The Core 8 Flex Core Nano, they're about half of a Core 110. So even they're going to be about here. So still significantly more powerful than all these other, other products that are out there. That's processing power. However, we've also got flexibility. So like I said, having an Intel processor means that we're not constrained by what that processor is designed to do. It's designed to do whatever the software asks of it. And that's a key theme here at Q-SYS, is that we don't like adding in lots of little widgets, little hardware widgets, little boxes that do a very specific job, which is something that typically we see all over the AV industry. And it's not something that anyone gets excited about. Consultants, integrators, customers don't like all these little widgets with a power supply and lots of points of failure all kind of chained together to make a system. And that's why, as much as possible, we do as much of that kind of thing in software, okay? So on the screen here, I've just thrown up a load of features which typically require, an additional piece of hardware that in Q-SYS are just using software running on the core and Q-SYS peripherals. And that's something that we do more and more and more, and you're going to see more from us in the future, is things that have always been hardware being replaced where it makes sense with software that's going to be lower cost, easier to deploy, and always in stock, which is always handy, okay? So that's Q-SYS processors, all right? And then what happens between a Q-SYS processor and all of these other Q-SYS products, okay? Like I said, whether we're going to be adding in cameras, other video products, audio products, touch panels, or something else entirely, all of the Q-SYS peripherals are all made by the same team. They all run the same software as well, and they all communicate with the core in a standardized way, okay? So we're not dealing with different systems for different types of jobs. It's all the same system. Now let's start off looking at audio, okay? How can we add in some audio peripherals to Q-SYS? Well, here we have a Q-SYS core, okay? And let's say this is a Core 8 Flex. Now, as it happens, that Core 8 Flex has some audio I/O on it. It's got analog audio I/O, and it's also got a USB connection, which is going to do audio and also video to and from a computer. Now, that's just what's on the core itself. Much of the expansion that you're going to see is going to be done via the network. So all of these products, all of Q-SYS is designed in a network first way. Everything is designed to work fundamentally over an AV network. Now, the protocol we use for audio, but also for all the other interconnectivity between Q-SYS devices is called QLAN. And QLAN is essentially a bundle of lots of different standard IT protocols. It can run over any gigabit network with the right configuration applied, but we don't, need specialist switches or anything like that. And here we're going to be using that for audio. So this means I can add in some Q-SYS peripherals, which are audio peripherals. And that might be PoE loudspeakers, PoE microphones. It might be something like this great big, very high power multi-channel amplifier. It could be these audio I/O devices. And like I said, all of the configuration for these is all done in a standard way. So unlike a typical AV deployment where you're logging into each device individually and setting up exactly what it needs to do, what channels it needs to receive, we're not going to be doing that. We're just going to be communicating with the Q-SYS core, telling it what to do on a system level. And then in the background, it is telling each of these devices what they need to be doing, what they need to be receiving, and how they need to work. Much, much easier to deploy. But of course, we need to work with third-party devices as well. There's many fantastic third-party audio devices out there. So all of the Q-SYS cores also support Dante and AES67. So you can integrate third-party, microphones, I/O devices, whatever it might be. All right. So that's audio. We can just do all of this audio expansion on the network. Now, what about video? All right. Video devices. Well, in the world of video, there's typically two sides to it. Okay, so I've got a handy little slide here, which is going to talk to the two sides of video we might have in an AV system. Now, the first one is going to be content, video content that we need to put on a screen. Okay, and when we get into larger systems, more complex systems, there's a huge benefit to encoding that onto the network, because it means we can have any number of inputs, any number of outputs, and send anything anywhere, which is great. Now here under the table where this person's using their laptop, we have a video encoder there. So that's receiving HDMI and it's encoding that onto the network. All right. Now we've got a display and there's a decoder there and it's decoding that off the network. Again, this isn't some separate product line. These are just different Q-SYS peripherals. And much in the same way we might add audio peripherals, we can add video peripherals. It just depends on what kind of inputs and outputs to the system that we need. But the other side of video is conferencing video. So this is where we're going to have a camera. And typically in a conferencing system, you might have a USB camera that needs to go across the room, connect to a PC. And this is where, again, we start adding lots of widgets and extenders and hubs and switches and things like that. We don't want to do any of that. So what we've got is a camera, which is putting video directly onto the network. And then instead of decoding that to HDMI, we're decoding that to a short point-to-point USB connection. Okay. And in this particular example, this device here is actually doing both those jobs. It's encoding HDMI onto the network and it's decoding the camera feed off the network to USB. And that means that this device here can see that and can work with that. The key benefit to all of this is we can have as many inputs and outputs as we need, as many different PCs, BYOD, room PCs as we need, just based on the number of peripherals that we add. All right. Now, we've also got control. And of course, in terms of hardware, when we think of control hardware, one of the first things we're going to need is controllers for the system. So here we've got some Q-SYS touchscreen controllers. They're called the TSC range. Okay. And these let you deploy user interfaces that are created directly in that Q-SYS environment without needing an additional control processor. So we can add these in, and again, the way they interact with the core is the same as everything else. The other part of control, though, which we do sometimes need, is when we're controlling devices that aren't network devices, which happens quite often. So here we might add some control I/O peripherals. We've got here the GPIO serial connections and also infrared if we need to use that as well. And these all fall into what we call QIO, so Q-SYS inputs and outputs. Okay, so we can add these in as well as needed to interface with, offline devices, if you like. Cool, so there we go. We've got the Q-SYS products. We're adding them as we need to build the system. We're then going to choose the core that we need to handle all of those products. And then, of course, we can integrate with all these other third parties and also do, some particular control integrations, which we haven't even gone into yet. We're going to do all of that later, but you can see here, this is essentially how Q-SYS works. Really, really simple, really scalable, and also very powerful. Now, this is a kind of, like I said, it's a sort of conceptual layout of how these things interact. Here I've got a more physical layout, and this is again where it's really easy. So when we start to do drawings and diagrams for how things are going to connect, instead of having lots of proprietary connections between different AV products, it's essentially going to look a little bit like this. We're going to have the core, we're going to have a network, and that could be a dedicated AV network. That could also be a client network where the client actually says, no, thank you, I would like to have everything on my internal network. That's fine as well. And then we're just adding the peripherals to the network that we need. Okay, so this means that when you look at the drawing, you do typically just see lots of different peripherals connecting to, other things like displays and PCs and that sort of thing. But at the end of that, it's just connecting to your network. So really easy physical layout And that means, of course, the whole thing's also reconfigurable via software because you've not got a specific hardware connections that do a very specific job, which is great. At the end of all of that, because you've got this core as the single source of truth for this whole system, all right, we've got a single thing which is doing all the audio, the video, the control, and all the monitoring and management of everything locally, including the third-party devices. It means we can have a single connection to the cloud, and this is going to allow us to monitor and manage the entire system from anywhere, okay? And not just monitor and manage it, but actually program it and commission it if we need to do that as well. So we'll talk about that later. And again, this is really only possible because we just have this, you know, all-knowing core that's managing everything. So guys, there we go. There is an introduction to the whole Q-SYS platform. Any questions at this point? Throw them in the Q&A section for me. And just before we move on, I just want to mention that we're talking a lot about corporate AV in this presentation, mainly because corporate AV just encompasses all of the different things that we usually do with Q-SYS. But actually, Q-SYS started out in theme parks and also in transportation, things like airports, train stations, that sort of thing, cruise ships as well, because those are the systems that needed those huge, you know, amounts of channel counts back in the day. But now you're going to find us in corporate, in themed entertainment, in transportation, also government installations, hospitality, and higher education, particularly since, you know, remote learning became a really, really big thing. So if you do have any questions that pertain to specific types of installation, feel free to put those in the Q&A as well, even though I'm mostly going to be focusing on corporate in this presentation. So speaking of that, we need to do some system designs, guys. We are going to look at a meeting room. We're going to look at how would we design this? You know, what kind of cores are we likely to need? What kind of audio devices? How do we use USB bridging effectively here? And then we're going to do a system design together. Okay. Remember to stay hydrated when designing Q-SYS systems. Right, let's have a look firstly at the room we're going to be working with here. So here it is, okay? This is a, you know, not a small room, not a big room. It's a sort of medium-sized meeting room here. And the requirements are pretty straightforward. You know, it's going to be a BYOD room. We want to have microphones on the table. We want to have camera. We want to have room control, automation, a touch screen as well. And we need to design all this using Q-SYS, and it's going to be really, really straightforward. We're going to start off looking at cores, okay? Because I have mentioned that the Core 8 Flex and also the Core Nano are typically a really good jumping off point into any system because they are very scalable, but also they can do very small systems in a cost-effective way as well. So let's start with this, and then we'll decide if we need to upgrade later on. Let's take a look at this, the Core 8 Flex. And we don't want to look at the front. It's an AV product. No one cares about the front of the product. Let's look at the back, okay? And on the back, you're going to see that we have 8 flex channels, hence the name, okay? Now, what this is, it's an analog audio channel. So it's going to do mic or line input with or without phantom power or a line output. And that's configurable channel by channel in the software, essentially. Okay, so you can here say, you know, maybe I want 4 inputs, 4 outputs, or you could have all of them be in or all of them be out, or like 2 in, 6 out, anything you want, channel by channel, input or output. Very, very handy. Now we've also got GPIO here. So this is good, of course, if you do want to connect to switches, relays, LEDs, things like that, to do a bit of in-room control. A couple of RS-232 ports, again, for devices that aren't on the network that we want to control. Then we've got the very important USB connections for bridging, which we're going to get onto very shortly. And here we have the network. All right, you can see we've got LAN A and we've got LAN B. Every Q-SYS core has LAN A and LAN B. Now, we can actually just do everything we need to do on LAN A on a technical level. We could do QLAN, AES67, Dante, Control, VoIP, whatever you want. You could do it all on LAN A. However, typically, in a corporate installation particularly, people might want to use LAN B for connecting to maybe a different network for the VoIP connection. Or maybe they want to have an AV network and an internet connection that are 2 separate networks. That's fine, okay? We can split things over into LAN B as needed, all right? Now, the Core Nano, like I said, is exactly the same. The only difference with the Core Nano is, ta-da, there's no flex channels, there's no GPIO, and it's cheaper. That's it. So you should be making a decision about these products based on that, essentially. Do you need loads of analog I/O? Or not loads, but do you need 8 channels of analog I/O? Or do you maybe need none because you're doing everything over the network, and you don't need loads of GPIO because you're not using loads of switches and LEDs, because you're using a microphone that connects to the network that has all of that built into the microphone, perhaps, okay? And that's going to decide whether you want a Core 8 Flex or a Core Nano. Very straightforward. Now, also with either of these products, we can mount them any way we want to, okay? So here we have multiple mounting options. You can rack mount them. You can also mount them on a surface, under a table, put them wherever you like. It's completely fine. All the mounting hardware is included as well. We're actually going to make use of that in this next system design, okay, which we'll have a look at very shortly. Now, what do we need to do to add in some audio? Because we do need some microphones and we need some loudspeakers. And the easiest way to do that is going to be to use some native Q-SYS microphones and loudspeakers, okay? And we're going to start off with this guy here. This is the NM series network microphone, okay? What a crazy product name that is. NM series tabletop network microphone for Q-SYS. So this is our very first native network beamforming microphone for the Q-SYS platform, and it's very, very easy to set up because just like anything else in Q-SYS, you connect it to the network, you configure it in the core, and you're away. All right. Now this is going to give you 4 lobes, okay, so 4 software definable zones that can do 360 coverage if needed, and of course you can enable these and disable them and configure them as needed. But it also has quite a few neat little control integrations, so you can actually use this as a kind of control surface into Q-SYS for conferencing. So you see there we've got a call, hang up, answer button there, okay, so you can actually answer things like Teams calls, Zoom calls, phone calls on VoIP, BYOD as well. You can answer and hang up using that, but via the USB connection that we're going to do. You've got, of course, mute control as well. You've also got a little blue button on the left there, which can be configured to do whatever you want. That's just a button that comes into Q-SYS that you can just use as a trigger in the control engine. And then also here, you do have the option to mute and unmute the microphone just by waving your hand over it, okay? So if you hold your hand for about a second, you will then, toggle the mute status of that microphone. And of course, this is because it was designed in the pandemic, right? So it makes perfect sense for us to have some touchless control there, so you've not got all these people touching this shared resource in the meeting room, okay? So we can add that in. We can add in 1 or 2 or 3, and of course, we'll see later on how that impacts the type of core that we need as we add many, many more microphones. All right, so there we go. NMT1, we'll probably add a couple of those into the room that we're working on based on the size of the room. Now for loudspeakers, we can take a similar approach, okay? We can add in some NL loudspeakers, network loudspeakers. These are PoE or PoE plus loudspeakers with ceiling mount option, a pendant mount option, and again, you connect them to the network. You have as many as you need based on what your room requirements are. And also we have here a sound bar option as well. So if you do want a surface mount PoE loudspeaker that's designed for conferencing applications, here's the NL SB42 soundbar, 4-inch low frequency woofer. Also, it's got a 2-way design, so it's got a high frequency tweeter as well. And also this has a little RGB LED on as well. And you can set that very easily to link with the microphone. Okay, so we can have as many NL speakers as we need, as many microphones as we need, and all of these will link together via the network, via the core as a single system. Now, just something I want to point out, we're not going to use this in the design we're doing now, but if you did have a Core Nano, and then you decided, actually, do you know what? I do need a little bit of analog I/O, or maybe you want to add more I/O to any other Q-SYS system. QIO, we mentioned it in the control section earlier, but you also have audio versions of QIO here. So very straightforward. There's ones with 4 outs, 4 ins, and 2 ins and 2 outs. Okay, so you can add these again as needed to expand the I/O on the network. Just one thing to point out, these are also PoE devices, of course, but you can daisy chain the network on these. So you can have 4 of them if you need to. That makes 1 rack unit, you daisy chain the network on them. The PoE doesn't daisy chain because there's no real standard for that. But then you can just daisy chain a power supply between all 4 of them and have a single rack unit with 16 IO maximum on there. All right, so we don't need that for now, but it is important to know about. So we've done some audio, we've got the mics and the speakers, very straightforward. However, how are we actually going to have the BYOD connection happen? How is that really going to work? And what about cameras? What do we need to do to add those in? Well, that's why we're going to talk about this Q-SYS AV USB bridging. All right, and you see in this picture here, there's a picture of a camera and there's a picture of a box, right? But actually nowadays, this is really woven into all sorts of different parts of Q-SYS. Many different Q-SYS products use this, and they all use it in the same way, which means it's going to be very easy to design a conference room using USB bridging. And the reason we've actually done this is to avoid this kind of situation that you see behind me. Typically, like I said, in conference rooms, you're going to have to use HDMI and USB, and I don't just mean to have a short point-to-point connection to hook a laptop in. You're going to need to use HDMI with extenders, with couplers, with matrices, and you're going to need USB also with extenders, also with hubs and switches, and you kind of have to bodge this whole thing together to make it work. And it's not a wonderful way to work. It does introduce reliability issues. It also means it's difficult to install because you can't terminate these kind of connections in the field, right? You can't get them in any length you want. And the cable's always too long or too short, right? You're never going to have the perfect length cable. And this is something we really want to avoid, okay, doing too much of this. Now, to be clear, when you're talking about a really small meeting room, like a huddle room or something like that, USB and HDMI, really great, work really well. For example, here, we've got a simple meeting room. We've got a PC in the room. We're going to have a USB audio device and a USB video device. And today, this would probably just be a soundbar, right? This would be one little soundbar with a single connection. It's going to do your video, your audio. It's going to work really well. It's going to work really nicely. Okay, that's not really where the problem is. The problem is that system designers typically will take this approach and then they're asked to do a bigger room and they start to kind of stretch out this approach to attempt to do the same thing in a bigger room. And that's where problems start to come in. So, for example, if this is a BYOD system and we've got these 2 different devices, well, now we want to make sure we're only presenting one cable, right? So, okay, we'll add in a USB hub. And now we've got hubs, we've got extenders. Also, this this camera might need control connections, might need power connections as well. So not shown here is all the other little widgets that power the widgets, right? So you get a lot of boxes going into the system. What if you want to have BYOD and a PC in the room as well? And this is a really common request, and it makes perfect sense that people would want to do this. Well, now we need a USB hub, but we also need a USB switcher, and that's going to move all of these peripherals between these 2 PCs. Essentially, what this is doing is it's equivalent to basically unplugging everything from one PC and plugging it in somewhere else. Now, that's probably going to work. It's not really recommended because you're going to have, if this is a Teams PC or a Zoom PC or a Google Meet PC, something like that, it's going to be pretty unhappy. It's going to say, all my devices have just gone offline as soon as you connect this laptop in. And then, of course, we have to think about how does this switching happen? Does it happen automatically? Is there a control system that we also need to add in? And also, we need probably more USB extenders for this laptop. So that's not going to be a lot of fun. Now, what if we need multiple cameras? What if we've got a high-end system, maybe a large boardroom or a large conferencing room, maybe a divisible space where we need quite a few different cameras and they need to work in different ways? Are we just going to be adding loads more cameras to the USB hub? Probably not. So let's move into that kind of space. Let's say we have here a high-end boardroom, for example, where we've got multiple cameras. At this level, just talking about the cameras, these are going to be PTZ units, almost certainly. They're going to need a power connection. They're probably going to need a network connection or a control connection. And of course, they're going to need a video connection as well. In this example, they're HDMI, and we've got here HD base T, TX and RX. They're going to need power supplies. Then that goes into this AV matrix where we're going to switch between them. Somewhere this gets converted to USB. Then it goes into this USB switcher. It's all getting a bit stressful. And what about audio, right? We're certainly going to need a DSP at this level. So we've got an audio DSP going in and out of the AV matrix. And now we also need to add a control system. There's our control system, which we're then going to have controlling the cameras, the AV matrix, the audio DSP, the USB switcher. It's like a load of different boxes. This is what we're talking about, a load of boxes cobbled together to make this work. And it's not going to be much fun for anybody to work with. So instead, we're going to do what we do with audio. We're just going to use the network for everything, right? Because of the network, we can send anything anywhere. We can send audio to any destination. We can do the same with video and also with control, and we can power devices, and we can have any cable length we want up to 100 meters, and we can terminate the connections in the field. So let's do it. We're going to have here our Q-SYS core. This Q-SYS core is going to connect via the network, of course, but we've also got that USB connection that we saw on the back of the core earlier. Now, what that's going to do is that's going to connect straight to our PC. Okay, and instead of this being a long cable, this is a rack mount PC. This is probably right next to the core. We're going to have a short point-to-point USB connection, which is exactly what USB is perfect for. And the core is going to present itself as two devices. It's going to say, hello, I am a standard driverless webcam that, by the way, is certified for Teams and Google Meet and Zoom and everything else. And what that's going to do is essentially just be used on the PC straight away for its conferencing software. It's also going to say, I am a standard driverless echo cancelling speakerphone that you should use as your audio device for your conferencing applications. Okay. Now, the audio that we're going to send to and from that PC can be any audio in Q-SYS, but typically, of course, the mics go into Q-SYS, the mics go over USB to the PC, and the PC audio goes back down the USB and goes out to the loudspeakers after processing and everything else. But what about the video? Well, all we're going to do is add on a NC camera, okay? Network camera, of course. Everything starts with N, right? It's really, really straightforward. And this is going to need one connection. It's going to have one data connection, which will do the power, which will do the video, and will do the control. And of course, that can be up to 100 meters because it's Ethernet, right? So there we go. We're going to connect that into the network. That camera is going to be putting video onto the network. The core is going to pull it off the network, transcode it into USB webcam, format, essentially. Do all of this with negligible latency, and the PC just sees a USB webcam with some very nice video coming in. So that's great. That's really nice and simple. You can see there's no widgetry in the way. We've just got network and we've got a simple USB connection. But where this gets extremely powerful is when we need more than one camera, for example. So now if you said, that's great, but actually I like two cameras, and traditionally you're then going to be like, oh, that makes it really complicated. No, you just add the number of cameras that you want, whether it's one, whether it's two, whether it's five in this case, because why not? So now we've got 5 cameras all putting video onto the network. The core can now seamlessly switch between all of those to get the video that's needed, but the USB connection is maintained. So the PC doesn't know there's any switching happening. It's just getting different video sent to it via a persistent webcam connection. All the switching is happening in the network. Now, the same thing goes if we want to add in more PCs. We're not going to add in something in the USB domain. We're going to add in something to the network, and that will just be another Q-SYS device that does USB bridging. Okay, so now we have lots of different Q-SYS devices out there that can do USB bridging, and we can add that under the table. Again, short point-to-point USB connection, exactly the same thing that the core is doing, and we just connect it to the network again via, a normal network connection, doing PoE as well. So of course you can see here that whether you want one camera, one PC, or you want to have 10 cameras and 10 PCs in some, maybe like crazy active learning space, for example, that's completely fine. You can do all of that, and it's going to be very, very straightforward to install, program, and also monitor and manage and keep it going. Now, talking about the programming, obviously this isn't a programming training course, but I do want to show you just how this looks in the programming environment. So this is Q-SYS Designer. Like I said, this is the one piece of software which we use for all of the Q-SYS programming. And here you can see what we're looking at is a audio DSP section here. Pretty straightforward. But what we're going to do is scroll down and we'll see in the same environment, we've got our cameras there. We've got a video section. We've also got some control integration down the bottom. But let's say I want to add more cameras. So I'm going to add them to the network physically. And in the programming, I'm just going to add them from this inventory section on the left, just going to drag those in. And as long as they're named correctly and that matches what's on the network, it's going to work. Now, this blue box in the middle, this represents the switching on the network. So I'm able to set up what cameras can go where. And I'm going to add another USB bridge on the right-hand side there. So now, instead of having one camera, one bridging destination, I've got 3 cameras and 2 bridging destinations, and any of the cameras can go to any destination. And then I just run that config and that's it. I have had a little message saying that you can't actually read the text. That's fair enough. Sorry, that's I guess that's a Zoom thing. But it is actually got cameras on the left, switching in the middle, and bridging on the right. And that's essentially it. Now, let's just talk about what cameras we can actually use here. So essentially in the NC camera range, we've got here a few different form factors. This is the NC110, okay? And this is a small form factor EPTZ 110-degree field of view 4K camera for smaller spaces where you need a high field of view, or for a really big space where you want one camera that gives you an overview, okay? And this can be added onto the network in exactly the same way as these other cameras, okay, which are the PTZ range of NC cameras. So here you've got the NC 20x60, the 12x80. They're exactly the same in terms of how they operate, just different lenses. So the 20x60's got a 20 times zoom, 60-degree field of view on the wide angle, and this is a 12 times zoom with an 80-degree field of view on the wide angle. So just good for slightly big or slightly smaller spaces. The neat thing, of course, is that when you get into those high impact spaces, you can mix and match these as needed with as many as you want. So quite typically in a high-end, collaboration space, you might have a few PTZs around the room to cover all sorts of different angles. You might also have a NC110 that's able to see the whole room at once. So for example, when nobody's speaking, maybe you would switch to that so everyone can just see the whole room. And when someone speaks, we could automatically trigger camera presets based on that, okay? Why? Well, because Q-SYS is, instead of it being lots of different systems, you've got the one system controlling the cameras, receiving the audio from the microphones, and that same system is the control system. So it's super simple for us to do these really neat integrations between audio and video that would typically be quite hard. All right. So there we go. We've got the cameras, we've got the bridging, we've got the audio. Let's do a system design right now. Let's go into that room and see how it's going to work. So we're going to add in a Core Nano, and I'm using a Core Nano because I really don't have much of a requirement for analog audio in this space, which is nice and simple. Now I'm going to go over here. We're going to have a network switch. Now this could be a client network. This could be a dedicated AV network. We'll add in a camera, and of course we could add in more cameras as needed. And then we'll come over to the table here, and we're going to add in 2 NMT1s. Remember, each of these has got 4 mic zones on it. This is like a 10-seater room, so I think that's a good number there. Of course, we could have 3 if we need that. Now, we'll also add in a laptop sold separately, and we'll also have a few NL speakers here. And again, if we decided we wanted just 1 speaker to value engineer this, or we wanted to have 6 or whatever, that's fine. We're just going to be adding them to the network or taking them away. Doesn't mean we need to think about amps and cabling and other things. Now, in terms of the connections, in this example, we're not going to do anything fancy with network video for content sharing. We're going to do that in the next section. So for now, it's got one of my least favorite things here, a long HDMI cable. We're using the USB bridging connecting to the core, of course, so that the laptop can get access to the mics, the speakers, the cameras. And then everything else is just data, right? So we're connecting the core to the network. We're connecting the mics, we're connecting the loudspeakers, we're going to connect the camera, and we haven't talked much about control yet. We'll do that in the next section as well. But when we add in a touch panel, that's also just data. And all of this data is going to be PoE powering all the devices. The only one it isn't doing is the core, which is going to need a power supply, of course. But there you go. You can see that's super simple. You can see that if we needed to double the size of that, we don't have to completely rethink our approach necessarily. We can just add in more speakers, more mics. And if we need to make it smaller, same story, okay? So really nice and simple and scalable. And as you can see, if we look in the room, everybody is extremely happy. So well done, guys. That's a great job you've done there. Now, what we're going to do is take a little break now. We're just going to take 5, and we're then going to come back and talk about high impact spaces. What I'd like you to do, if you can, just make sure you're okay to log in to the training website, because that's where the exam will be later. And it just speeds things up if you can just log in now, because sometimes people go, oh, I've forgotten my password and what have you. And you have to spend some time at the end sorting that out. So do that, get a cup of tea, which is what I'm going to do. And then we're going to come back and scale this up and talk about great big systems. All right. See you in a little bit. All right, everybody, we are back. Okay, and let's have a look at what we're going to do in this next section. Okay, so we are going to be talking about, like I said, bigger systems. But one of the first things people ask is, okay, well, how do I know? I've designed this great big system. How do I know what core I need at this point? Do I need to go up from a Core Nano or a Core 8 Flex to something bigger? What's going to be the driving factor that's going to say, oh, now you need a bigger core? Okay, well, it's actually fairly straightforward, particularly when you're doing conferencing, because there are a few really key factors that are going to push you into doing a bigger Q-SYS core. Now, here, what we've got is the actual specifications of the Core 8 Flex, the Core Nano, in terms of what's relevant to what we're doing here. Okay, so local I/O, we've talked about that quite a bit. We know that that's different between the 8 Flex and the Nano because of the Flex channels. Now, network audio, we said that there's 64 channels by 64 channels total. Okay, but we haven't talked about Dante. So that's going to include QLAN channels and AES67 channels and Dante. Okay. Now, your Q-SYS peripherals, your mics, your speakers, they're going to need QLAN channels, of course. But with Dante, you get 8 channels in and 8 channels out included if you want to use that. Okay, so that's going to be probably okay for a fairly small-ish room. Okay, you can actually upgrade that to 32. So you can go from 8 to 16, or you can go to 32, depending on what you need. And that's just a software license that you can add on to your Q-SYS core. Okay, so no extra hardware needed for Dante. Now, what about echo cancellation? And this also ties in with the NMT ones. So if we were just using third-party microphones, we could do 8 channels of echo cancellation. Okay, so that could be 8 individual mics. That could be a ceiling array microphone that gives you 8 Dante channels, but you can do 8 channels of echo cancellation on these cores. Now, when we have the NMT1, the actual beamforming that the NMT1 is doing and the echo cancellation is done inside the core. Okay, so we think about that as well. Now, it turns out that you can have 3 NMT1s on those cores. So that's actually going to give you 12 channels, which is kind of cool. So a few more channels with the NMT1 than with other mics. And also, once you've done that, you are actually going to have some other AEC left over. I'm not going to go into how that all shakes out here. Do go onto the NMT1 product page where you can actually say how many mics you've got and what core you've got. And it's going to tell you how many third-party AEC channels you have left over. The key thing we need to know is that the AEC and all of that is a bit more efficient using the first party mic, because obviously we're controlling the processing end to end. Now, audio players, we didn't really mention this, but every Q-SYS core supports audio playback from its internal SSD, and these will do 16 channels of audio file playback. Okay, which is kind of cool. You can use that for, of course, background music, things like that. Also for voice prompts. So people are doing things now where, you know, you connect your laptop, and sometimes in a meeting room, if you're, you know, a sort of non-technical end user, you plug it in, you're like, did it work? You know, oh, it did work. And there's a delay in the screen coming on or whatever it might be. So you can do things where, you know, as soon as the USB is connected, a little voice just plays out, USB connected. And then, you know that that's worked. And that's easy to do. You can just do that with the audio players on the core. And then also relevant for conferencing, well, if anybody's using VoIP anymore, I'm not sure how popular it is now, but you can do 2 VoIP lines. So 2 phone lines on the core itself. Okay, cool. So we were using 2 NMT1s in that last system design, weren't we? Now we could do 3 and that would all still be okay. But beyond that, we're going to need to upgrade the core in some way. So how are we going to do that? Well, it turns out we can do that with hardware or we can do that with software. Okay, so there's 2 options here when we're moving up from a base level Core Nano, Core 8 Flex up to something else. So we have here Q-SYS scaling licenses. And much like I said earlier, we're doing a lot to, you know, lessen the need to add in lots of extra bits of hardware. So instead of needing to buy a bigger Q-SYS core, you can, with these ones, add on a Q-SYS scaling license, which is going to be a little bit more cost effective. And that's going to unlock different amounts of DSP for different applications. Okay, there's actually one for commercial AV, which is aimed at sort of hotels and background music and, you know, sports arenas, that kind of thing. What we're going to look at here is the collaboration scaling license. We can add that onto a Core 8 Flex or a Core Nano, and that is going to give us double the AEC, it's going to give us double the amount of network mic support, double the general purpose DSP, and also double the network audio channel capacity total. So now, if we chuck that on, we can see that we've got 128 channels of total network now. It doesn't let us do more than 32 channels of Dante. Okay, so that's going to be 128 in total, and you can still have up to 32 within that total of Dante. But now we can do up to 16 third-party mics with AEC, 6 NMT ones, and also we've now got 4 VoIP lines rather than 2. So this is going to be great for the bigger system that we're about to do. The other option, moving from the Core 8 Flex Core Nano up, would be to just use a Core 110F. Okay, Core 110F has about double the processing of a base level Core 8 Flex Core Nano. It also has lots more analog I/O, which is really where it can be useful if you need that. So here we have the Core 110, the back of it, and you can see we've got 8 flex channels, but we've also got 8 dedicated inputs and 8 dedicated outputs. So that's 24 channels in total. And of course, these flex channels are just like on the Core 8 Flex. All of these can be ins or outs channel by channel. Now, moving over to the other side, we've also got an analog phone line. If you need to go back in time and build a conference room, you can use that. We've also got RS-232, USB bridging, and we've got the network again. So much like the Core 8 Flex Core Nano, serial connection, USB, and we've got the network connections as well. So the real value in this is if you are needing a system with lots of analog I/O, this would be the more logical upgrade. If you don't, probably makes more sense to stay with the smaller core and do the software upgrade on that instead. Let's just compare the numbers again. So you can see that it is basically the same on a Core 110F as an upgraded Core Nano in terms of the network audio. Okay, so 128 total, up to 32 Dante. We've got 16 channels again of AEC. Actually, because the Core 110 is just a slightly older product and the processing works in a slightly different way, you can't do 6 NMT ones. You can only do 4, okay? Just so you know. And audio players is the same, and VoIP is the same as the upgraded one there as well. So the main difference, you know, other than the NMT one there, is you've just got loads of analog audio here, which can be really, really handy. So we're going to use one of these for our next room. And our next room that we're going to do is going to be a divisible room. Okay, we're going to have a bit more of a complex requirement there. So I think this is a great opportunity to talk about a few things. We're going to get into Q-SYS control and how that really works. And we're also going to talk about Q-SYS video in terms of video content distribution, okay, the NV series. Then we can build our upgraded room, okay? Let's start off with control. Just notice no questions yet, guys. So either everyone is extremely confused or I'm just explaining it really well. It's probably the former. So Q-SYS control here, how does this really work? I keep saying it's integrated, it's just part of Q-SYS, you've got your touch panel, that's it. Now we're going to look at actually how do we add this in, okay? So Q-SYS control. We say that it's, firstly, it's integrated. So for the reasons that we said earlier, it's not some separate product, is not a separate processor, and you saw in Q-SYS Designer, it's just in the same environment. All of the control interactions are happening within and alongside the audio and the video interactions. It's also very simple. So if you don't come from a Q-SYS control background or even from any control background, we give you a load of tools to make it really, really easy to program this. And also, this is one of the reasons a lot of end users are really liking Q-SYS control, is because if they want to make a very simple change, it doesn't require, you know, a degree in control programming to do that. Now, it's also very scalable. So although it starts off very, very simply, there's also a lot of advanced programming tools for the advanced programmer to do very complex things. And because you've got that Intel processor at the end of the day doing all of this, you've got a huge amount of processing power to do a lot of different things. And then also it's open. So unlike a lot of other control platforms out there, we don't say, you know, you can only interact with this if you've done X, Y, Z. Anyone can download Q-SYS Designer. Anyone can start to run it in emulation mode and actually test things out on their PC. Anybody can do the Q-SYS control training. And most importantly, we can all build modules and share them for all sorts of third-party devices alongside all the official partnerships that we have with third-party manufacturers. Let's first talk about user interface. So if we need to do user interface deployment, there is a software feature for this. It's called UCI deployment. It's called the UCI deployment license. And you add that onto your Q-SYS core and it lets you deploy unlimited UCIs to any type of viewer. So that could be a Q-SYS touch panel, an iPad, a Windows PC, a web browser, with an unlimited number of client connections as well, okay? And you can see here that we can build UCIs really, really easily. So inside the Q-SYS Designer software, you can just drag and drop controls from the schematic onto the user interface here and build UCIs that look, however you need them to look. And you can just style them by adding custom graphics and change the colors, and it's really, really easy to do. Then when you actually run the file, you don't even have to interact with the touch panel. Just like every other Q-SYS peripheral, you give that design to the core and tell it what touch panel you want what UCI on. And then the core just handles the panel in the background, gives it the UCI, and basically tells it what to do based on your Q-SYS Designer config. Now, we can also go more advanced with this. We can use CSS, which is how web pages are styled. We can actually use that to make much more specific styling decisions about different UCIs, okay? Now, let's just talk briefly about the TSC range. So TSC touchscreen controllers for Q-SYS. Here we've got a 7-inch model, a 5-inch model, and a 10-inch model. And these can run, of course, all the UCIs that you're going to design in Q-SYS. And you can see here, we can do lots of different types of styling with these. Now, these are a brand new design. They're a fairly new product. The key thing about this is they have a very powerful processor in the background, as you'd expect. So lots of new features coming out for these all the time in a very Q-SYS style, where we release the hardware, but then we're adding in lots of new features, particularly on the video side, with more to come there. So we can, of course, have camera previews on these. You can have 2 camera previews up to 30 frames per second, and there's no limit on other previews. So for example, if you had a big event space, you might have lots of cameras. You could just put all of those previews on a touch panel and allow for lots of clever interactions there. Much like the microphone and the soundbar, we have here RGB LEDs, and of course these can all be synchronized to show, room in use state, mute sync, all sorts of different things. Or you can actually customize each LED individually if you really want to do that. And another handy little feature is that these do have the capability to deliver audio video bridging. So like we said, where we have the bridging on the core, delivering camera and delivering audio to a PC, you can actually also have this at a touch panel as an optional feature, okay? And this is an optional feature because not everybody is going to want to use this on every touch panel, if they're in the wall or something. But if you do have a touch panel in a room that's a BYOD room, you can just connect your laptop to the touch panel to get the camera, to get the audio as well, okay? Now, what I want to talk about here a bit further is something that I've got a special slide for that I'm just going to bring up, okay, which is around Microsoft Teams and also Google Meet and with Zoom as well. So we can actually deploy UCIs onto the controllers for those room PCs. If you have a Teams room or a Zoom room or a Google Meet room, you've got a controller there. That's just going to give you the call control. We can actually use that as a virtual Q-SYS touch panel as well. So here I am in Q-SYS Designer again, and you see I'm in the schematic. I'm dragging controls from the schematic, and I'm just dragging them up to the UCI editor. This is what the UCI editor looks like. You can see it's not very pretty at the moment. It does have lots of controls on there, all from the schematic. And I mentioned we can use CSS to style UCIs. So we can actually add on a Teams style. So this is being used in Teams in this example. And there we go. Now we have this following the Microsoft Teams brand guidelines. We've got the correct font, the correct color, and so on. Now, those buttons I just added down here, I'm going to choose the right CSS class for those. And now they are styled in the right way as well. Okay. Now, what we can do with that is we can actually present that through this system here, which I'm not really going to go into now, onto this Teams panel. And that means that the user is going to see this. They can just press a button on the Teams GUI and they get taken to room controls. And this is just a nicer user experience than having multiple different touch panels. Okay. So of course, like I said, we can deploy to these, Zoom, Google Meet, web browsers, Windows PCs, iOS devices, and that's all delivered via the UCI license. Next, we need to talk about control, right? So that's user interface, but how do we actually control and interact with third-party devices? Well, for this, we have a no code option here. So we kind of break this down into no code, low code, and full code. Okay, depending on the kind of programming you want to do. If you don't want to do any programming, then you can do basic interactions with third-party devices, sending commands out to them in a sort of one-way fashion, using just the things that come with Q-SYS as standard. However, if you add on the scripting engine software feature, that is kind of replacing you adding on a separate control processor. Then that means that you can use this firstly. So this is called the block controller, where you can essentially build code using different blocks and you don't have to learn a language. This allows you to do very powerful things with third-party devices without actually needing to learn a load of code. So great for people who are new to control programming or new to Q-SYS. But then you can also use full-on code. This is the Lua scripting language. This is a language that's designed to be embedded within other systems like Q-SYS. Very, very easy to learn. And this is how you can write basically full-on programs within the Q-SYS environment to do all sorts of different things. And this is how our technology partnerships work. Okay, so we have Q-SYS technology partners, which are third-party manufacturers, which is an ever-growing number. I think we're up to like 50 or 60 technology partners now that can have essentially certified Q-SYS plugins, which you can just drop into Q-SYS, and you're controlling third-party devices then without doing any code, in the same way essentially that you would control a first-party native Q-SYS devices. So really, really easy to control third-party devices using the technology partner program. But if you want to, just scripting things yourselves with the programmers that you have if you're at a system integrator. We actually have a little question here saying how many Teams touch panels can be controlled by a single Q-SYS core system? Okay, that's a really, really good question. So we did mention earlier on, very briefly, that the Core 8 Flex and the Core Nano have a limit of 32 Q-SYS peripherals. Okay, now that would be a touch panel or a camera or a QIO device or anything, right? Any Q-SYS peripheral that's tied in to that core, or third-party devices can be peripherals as well. So essentially that's the limit, 32 in total. Okay, you could have 32 team systems and that would be fine, and no other peripherals. Typically though, what we see is that the most you would typically do would be like a two-way or a three-way divisible room. You could do that with an upgraded Core Nano or a Core 8 Flex, and in that case you'd be talking about 2 or 3 team systems. You could do more than that. Really the limitation is in 32 peripherals for the whole core. Now the Core 110 and up don't have a peripheral limit in total, and you could actually do there's no imposed limit for Teams UCI controls. You could do a lot of them. Really, realistically, you're going to be limited by other factors before you get limited by that. Things like AEC that we've spoken about. We have a question here. Do peripherals include analog audio? Now, Craig, I'm not sure if you mean each analog audio channel. If you have like a QIO box, the one with the analog IO in and out, that's going to be one peripheral. Okay. Also, if you added, like a great big Dante analog in and out box, and you're controlling that with a Q-SYS plugin, that would be one peripheral as well. So we're not looking at the number of channels or anything like that. It's just like each Q-SYS box that you're adding in, essentially. Okay, great questions, guys. Very, very good questions. Okay, and speaking of which, just remember on the control side, we do have these QIOs. So if you do need to add these in to control third-party products, not via the network, you can just add these in and do that really, really easily. Okay. All right, excellent. Now let's have a look at where we're at. We need to end up doing a system design here for a large multi-purpose space. However, we need to talk about video. We've done Q-SYS control. Very easy to add that in. We're going to now have a look at Q-SYS video and all the possibilities that that brings. Okay, so this means we're going to start talking about the NV series. No special prizes for guessing what NV stands for. Okay, so here we have two products here. This is the NV32 and the NV21. What these products do on a surface level is they encode and decode HDMI and USB-C video signals. Actually, they do a whole lot more than that. and they are really products that are very multi-purpose and can be deployed in a number of different ways. Okay, what we're going to do is talk about the NV32, because that can do sort of everything in the video sort of department in Q-SYS, and then we're going to have a look at the NV21, which is obviously smaller, lower cost, and does a subset of that. So here's the NV32. This is just another Q-SYS peripheral that we can add, but it's quite a big one, okay, because this does a whole lot of video I/O and audio I/O on a single box. Okay, now what we want to do is connect HDMI, encode that to the network, and also have stuff come off the network and decode to HDMI as well. Now what you have here is not one in or one out. You've got 3 ins and 2 outs, and this one product can be configured as an encoder or a decoder. Now as an encoder, you can actually have 3 HDMI connections all get encoded independently as 3 separate sources up to 1080 60 resolution there, and they all go off to the network independently. So it's really like having 3 encoders in one. It can do 4K 60 resolution, but not 3 at a time. Okay, now you can also have a local output on there, so you can have a local output for a confidence monitor, for example, and you can think about higher education here. For example, maybe you have a lectern, and at the lectern you've got multiple video inputs there. You can just have an NV32 encoding all of that at once and giving you your local confidence monitor as well. Now as a decoder, it's the same kind of idea. We have 2 outputs, and up to 1080 60 resolution, both of these outputs can be active at the same time and be fully independent. So we've got 2 decoders. We can decode from any network source onto these outputs, and also we can also switch between any network source and any local source on the decoder. Now in either mode, doesn't matter whether it's an encoder or decoder, you see we've also got this USB connection here, and this is exactly the same as USB bridging on a core. So you connect that to a PC, you're presenting cameras and audio. So whether it's an encoder or a decoder on the HDMI side, it's always going to allow you to do USB bridging with cameras and with audio. It's also got here analog audio in and out, 2 ins and 2 outs. It's also got GPIO, RS-232, and it's got USB-As. And we've actually seen USB-As on the other products, some of the cores, and I haven't mentioned anything about that. These USB-As, what they do is they are going to allow you to encode and decode HID signals. HID meaning human interface device, USB keyboards, USB mouse, USB touch from a great big touch screen. That can go in here. You can route it through Q-SYS and take it off into a PC anywhere else. That works on the Core 110, on the Core Nano, the Core 8 Flex, and the NV32, and a lot of other products as well. Okay, so anyway, we've got here encoding, decoding. So let's talk about how we could use that in a space. Here we've got a room, okay, and what I'm going to do is just add an NV32 under the table. Now what this is going to let us do is connect a PC. We've got a USB connection here. We've also got a HDMI connection as well, right? And now we're delivering camera and microphone via the USB connection. We're bringing content off the PC onto the NV, and we could also have more. We could actually have 3 HDMI connections at the table just with this single NV32, which is really, really nice. Okay, doing this with other products would take quite a lot of products to do just that. Now let's say at the display side, we've also got maybe some other inputs. This is obviously some kind of weird hybrid higher education meeting room thing. Not really sure where I was going with this, but we've got loads of sources. Don't ask me why. So we've got a document camera. We've got a lectern with a laptop. We've got a PC. Okay, we can have one NV32 decoder decoding everything from the table, and also ingesting from these local sources and doing USB bridging to the PC at the same time as it's doing USB bridging over here. And we've got 2 displays. So now the end result is that either of these displays can independently switch between any source, any of the 6 sources in this room. All right, just with 2 boxes, 1 encoder, 1 decoder. Awesome. So that's really nice. Now, however, what if we actually don't want all this at the table? What if we just want 1 laptop connection? Now the NV32, it's not a low-cost device. You can see how much I/O it has on it. That's great if you're using all of that. If you're not using all of that, it's not the most efficient way to go. So That's where NV21 comes in. And you see this is called NV21HU. That stands for HDMI and USB, as in USB-C. Because what people really want is they want the ability to connect a single USB-C connection and get device charging, USB bridging, and content output onto the network. And that's what this does. So that single connection there is going to let you do all of the interactivity with the laptop that would normally take a USB and an HDMI. We just do it on the USB-C, and we're doing device charging if we have a power supply on this NV21. Now, as an encoder, we can encode from USB-C or from HDMI. We've also got an HDMI out, so we can put that on a confidence monitor again. So it works in the same way as a NV32, similarly, anyway. And as a decoder, same kind of thing. We've got a decode to this HDMI out, which can be from any network source or from the local HDMI or from the local USB-C, okay? We've also got RS-232. We've also got USB-A for HID, for the keyboard, the mouse, and all the rest of it. And it's, again, a network connection, okay? Just a note on power requirements. The NV32 is, you know, a pretty powerful product. This does work on PoE, but it's PoE++, and not only is it PoE++, it's the 802.3 BT spec. And if you give that a quick Google, which I did before the webinar, because no one remembers this stuff, 802.3 BT is 90 watts. Okay, so that requires a 90 watt capable output on the switch. However, you can also just connect a 48 volt, 1.5 amp power supply instead and not use PoE. Now the NV21 requires PoE++, but there's a massive range of PoE++ specs. It's the 40 watt or thereabouts PoE spec for that one. However, if you are doing device charging on this, this will do up to 65 watt of device charging. And at that point, you need the power supply. So we do obviously sell a power supply with this as well. So you connect the power supply to it, and then you can do device charging, encoding, decoding, everything else, you know, pretty easily. Have a question here about video formats. Does the HDMI output do 4K 30 or 4K 60? It's up to 4K 60. Good question. Also, the encoding and decoding on this is not like JPEG 2000 or one of the more sort of lower quality codecs. It's always 444 chroma subsampling. Okay, so there's no subsampling of the color at all. It's all within a 1 gig connection, and it's an adaptive bit rate. So the bit rate can be up to 750 megabit per second, but it's motion dependent. So if you're just showing a spreadsheet, you'll actually find that the video bandwidth is extremely low. Even at 4K 60 for static images, it's like 20 megabit per second. But then you could show a full-on, you know, 4K 60 nature documentary or something like that, and the bitrate will just dynamically ramp up and down as the motion in the video increases and decreases. Okay, so 4K 60, 4K 60, but remember the NV32 can have dual output, and then it's 1080 60. Okay, so that's the input and output format. Also, all of the inputs and all of the outputs have scaling on them, so you can of course have a 4K stream go to a 1080 output or vice versa, and that's all totally fine. Now we have another question here about dedicated network switches, which is something we're going to talk about. We're just not going to talk about it now. So I'm going to leave that in the Q&A here, and we'll come back to that in a little bit. All right, great questions, guys. Loving it. So let's have a look at how we can use NV21. It's really straightforward, okay? It's exactly the same system as before, but I've just done one laptop at the table, and I've got a NV21 instead of an NV32, and I've got a single USB-C connection doing bridging and charging and also content encoding. Great. Now, let's have a look at how we can actually use this in a bit of a bigger space, okay? One thing we need to do before we do that is just mention something about loudspeakers. So I haven't got any loudspeakers in here. Did you notice? So the reason I haven't done that is because in these larger spaces, we could, of course, still use the NL series. We can still use network loudspeakers and have loads of them in the ceiling. That's fine. You can use as many as you like up to the core's, you know, peripheral limit or network audio channel limit. However, it does get to a point where, you know, if you've got 30 ceiling speakers and they're all network loudspeakers, that's 30 data connections. We're not daisy chaining the data on these, right? That's a lot of PoE budget as well. And that could be really valuable if you want to play different things to each speaker. That's actually a really great way of doing it. But if you don't, if they're all just playing the exact same thing, then it's not super cost effective. So then we might go back to the traditional approach of using a 100-volt line with lots of 100-volt ceiling speakers. So for that, we've got here amplifiers, of course. So we've been making amplifiers for over 50 years. This is the most recent addition, SPA, small power amplifier, Q for Q-SYS, because this is a 2-channel or 4-channel amplifier that can do low impedance or it can do 100-volt line. And it's also a Q-SYS peripheral. So just like all the other Q-SYS devices we've been talking about, exactly the same thing. Programmed in Q-SYS Designer, controlled and managed by the core. And you can see over here that we have 2 or 4 channels output, 60 watts per channel, by the way. And you can bridge a pair of channels to get a 100-volt line, and then you get about 120 watts, I think, on a bridge line. Also, just a handy thing that it adds is GPIO, a little bit of GPIO, and 2 flex channels. And these are flex channels to any part of the Q-SYS system. Why? Well, because if you have a Core Nano, you might have a Core Nano paired with an SPA-Q. It just means that you have a little bit of analog audio in the system should you need it. And that's a really common combination, Core Nano with an SPA-Q, because sometimes people do need 1 or 2 channels of analog audio, and they need that much more often than they need 8 or 24 like you get on a Core 110F. What about loudspeakers? Well, of course, you can use this with any passive loudspeakers. We make a lot of passive loudspeakers. We've been doing this for a very, very long time. Here is the acoustic design range, which is the more premium end of the installation loudspeaker range. I'm not going to go through all these loudspeakers now, but there's a huge selection. So we got here ceiling speakers, low profile ceiling speakers, white and black, pendant speakers, 4-inch, 6-inch. There's subwoofers as well. We've got surface inch speakers here for like a normal form factor, columns for when we want that narrow vertical dispersion, subwoofers as well in lots of different styles. All of these are also IP rated. You can mount them outdoors if you want. They're also all Teams certified, which is really cool. So you can use any of these speakers to make a Teams room. The room will not lose its certification because you're using some non-certified loudspeaker. Anyway, we're going to use some of these along with SPA-Q, along with video, and along with control, and with an upgraded core. Right now, we're going to do a system design. And the system design looks like this. Divisible room, right? Really common requirement, particularly post-pandemic when people are going back to the office and they want to have flexible spaces, spaces that could be a meeting room or 2 meeting rooms, or could be a training room, or could be an all-hands meeting space. Now, this is where that network and software approach that we have is very good, because we can just configure everything in software, not worried about the very specific hardware connections that we have. So you're going to see this is actually going to be quite straightforward. So here we have 2-way divisible meeting room. We want to have BYOD and an in-room PC in both rooms. Table mics, cameras, 2 cameras in each room, so 4 total, 2 displays in each room, ceiling speakers and column speakers at the front in each room. And obviously, when the rooms open up, we need to be able to send video, audio, control from any room to any other room, basically. So let's have a look at how this is going to work, guys. We're going to start off just doing room 1, okay? Now, let me get out of the way here. We're going to just do room 1 to start with. And let's start with that loudspeaker requirement. They need to have column speakers and ceiling speakers in each room. So I'm adding in my SPA-Q. And here we have the SPA-Q going to a pair of column speakers. These are 8-driver column speakers. And the benefit of column speakers, by the way, is they have a very narrow vertical pattern and a very wide horizontal pattern. Okay, so this means that you can actually get a very good throw distance without the sound reflecting off the ceiling and the tables and the floor and everything else. Now, we're going to drive that from 2 channels of this 4-channel SPA amplifier. And I'm going to use the other 2 channels in bridge mode to drive some pendant speakers. Okay, so that's going to be nice and simple. 1 amp to do all of that. Now, we'll add in an NV21. So we need BYOD at the table. There's our NV21 at the table. We're then going to have a PC connecting to that. So we're going to do the bridging, the content ingest, the power supply, all of that on the one cable. And we'll add in some NMT1s, touch panel as well to control everything, and some cameras, 2 cameras. And you can see at this point, we're just adding stuff to the network. I don't even have to think about how this stuff communicates. It's just on the network, really simple. Then what we're going to do is have our display here. And I'm going to have a local PC. And because I've got 2 displays, I could have, 2 NV21s here, but of course, makes loads of sense to use an NV32. If we need 2 decodes and we're not fussed about it being 4K 60, then NV32 is a really cost-effective way of doing that. Then we have the PC connecting with HDMI and USB, so we're doing bridging there as well. Now we're going to use a Core Nano for this. Okay, this is fine for one room. It's going to work really, really nicely. Okay, great. Now we're just going to copy and paste this. Okay, so instead of extending everything off of room 1, it's not like that. We're just going to add in the same exact peripherals into room 2. So there you see room 2, exactly the same copy and paste of room 1, but we've still got a single Q-SYS core. Okay, we're going to add the wall in there as well. We don't actually do walls, you have to get that separately. And then because now we've got 4 NMT1s, we're actually over the processing limit of the Core Nano. So that's okay. We're going to add in the collaboration scaling license onto the Core Nano. Now we can do up to 6 NMT1s. Now we can handle these 2 rooms absolutely no problem. And now instead of you thinking of it as a 2 separate systems than combine, it's more accurate to think of this as one system that divides. Okay, we've got 1 core, 1 program file, really, really easy to share content between all of these different encoders and decoders. And as a nice little touch, remember, we don't have QIO on the Core Nano. We do have it on that SPAQ, and that SPAQ might be in a convenient location to connect maybe a little wall sensor there. So we can connect a partition sensor into GPIO on the SPAQ. And it doesn't matter that it's on the amp, that's going to appear in Q-SYS Designer as GPIO input in exactly the same way as it would if it was on the core itself. So there we go. Really, really nice and simple. There's our system. You can see that even though there's really complex requirements here, that is going to be quite straightforward. Okay, guys, any questions on this large system before we change topics? I'll have a little sip of water while you think about that. Okay, no questions? That's fine. Okay, great. Here we go. Nathan, great question. Great question. Can this be done for up to 3 rooms? Well, Nathan, we can figure that out. Okay, so the limitation that we were worried about earlier was the NMT1s. A base model Core Nano can do 3 NMT1s. An upgraded one can do 6. This is 4. Okay. Currently, we've got 4 mics here. Obviously, this depends on the room that we're doing, but in this case, we've got 4. So yeah, absolutely. We could have a 3rd room here, no problem at all. And we would have to just double check that we're not going over our 32 peripheral limit that we have on this core. But I don't really think, no, we're not going to approach 32, I wouldn't have thought. So yeah, absolutely. So you guys can now work this stuff out, based on the limitations of the core in terms of mic count, peripheral count, audio channels, things like that. It will be very straightforward to say, well, do I need to go up to an even bigger core than that, or do I need to break it out over multiple systems? But no, you could actually do this fairly easily with a Core Nano that's upgraded. A 3-way room would not be a problem. Okay, we have another question here from Andre. Good to see you, Andre. So can the camera go to the HDMI connections in the room, or do we need to use the HDMI on the camera? Because I don't think I mentioned this, but the higher end, the PTZ models of the cameras do have HDMI output locally and SDI output. Well, actually, we can send that to HDMI outputs on the NV32. There is one limitation there. So these camera streams, they can go to the HDMI output on the NV32. They can only go to HDMI output 1 for boring technical reasons that I won't get into. If you just want to have a self view, those screens are right next to each other. You can just throw it up on output 1. That's totally fine, in my opinion. but you can't put it onto output 2 on the NV32. And the NV21 does not allow for this right now because it's just launched, but in a firmware update that we're going to add in later on, we will be able to do camera to HDMI on the NV21 as well. Now the question, can you use the touch panel to tell the room how the system is linked? Of course. So this can be done in lots of different ways. Sometimes people want it to be totally automatic. So you remove the wall, it all combines. However, some people want it to be on the touch panel. And what I've done in the past is you go up to the touch panel in either room and you press combine, and then it gives you 60 seconds to go to the other room, and the touch panel on there will have a prompt that says, do you want to combine the rooms? And then if they say no, actually, there's someone in here already using the rooms don't combine. So you would have to go into both rooms and combine it in both rooms. And yeah, that's completely fine. You could also use a combination of the things. You know, the room will combine when either the wall is opened or we do it on the touch panels. And when we do that, we'll have a state in Q-SYS that's like combined, yes or no, and that will plug into lots of other things like the video routing, the audio routing, etc. So yeah, absolutely, Nathan. Great questions. Okay, wonderful. So guys, what we're going to just touch on now, before we go into even bigger systems, and don't worry, we'll have a little break first. There's something else I want to mention about the NV32. We talked about encoder mode, decoder mode. There's a third mode we didn't mention, which is really important, which is called core mode. So you can actually take an NV32, you can change it into a Q-SYS core. What am I talking about? Well, basically, the NV32 also has an Intel chip inside it, and it uses that for a lot of video features, okay? Now, that can be changed into a different type of processing. Like I said, Q-SYS is just software, right? So we can change the way that that hardware is used on the NV32. We can make it into a core, and then it's actually a really great core for smaller rooms, okay? Let me tell you what I'm talking about here. So if we go into this little comparison, we've got core modes and we've got peripheral modes, right? What we've been talking about so far with NV32 is peripheral mode. So it's an encoder, it's a decoder, it's paired with a core that's managing it and everything, but it's the NV is a peripheral. You can go into any NV, you can drop down, click on the little drop down, it says mode, and you can select core mode and reboot it, and then it comes back as a core. And it now won't do streaming, it won't do encoding or decoding, okay? But it will get full Q-SYS core functionality. And I'm not talking about some kind of, it's not really a core, it doesn't do this, it doesn't do that. No, it does everything a core will do. The processing power is approaching that of a Core Nano or a Core 8 Flex, slightly less. It's also, of course, got loads of HDMI I/O. So now you've got 3x2 video switching locally without encoding and decoding. You've still got USB bridging, which is great to have on a core. You've also got a little bit of analog audio I/O, right? So not as much as the Core 8 Flex, but probably the right amount. And you've got things like GPIO, RS-232, redundant networking, and all of that good stuff, okay? So then you come back to a room like the smaller ones we were talking about earlier. We can then do a really slick system here with NV32 in core mode for a self-contained system, okay? Because now we've got one core, which is also our video switcher, it's also our audio DSP, it's also our control system, and it's our management and monitoring. Management? That's not a word. Let's make it a word. Get rid of monitoring and management, just change it to management. Sign here. Right. Let's talk about this system. Look how simple this is, right? So here we have a little system, NV32 in core mode right here, okay? Still dual output HDMI, and those screens now are able to switch between this dual output PC. So we've got two HDMIs going into the NV from the PC. Also, there's USB bridging there, of course. Then we've got a wireless sharing receiver. So that could be something like Mersive Solstice or Barco ClickShare or something like that. We're controlling that. We're monitoring that as well. So when sharing happens, we could switch to it automatically. Nice. So that goes in like that. We've got at the table here a couple of NMT1s that the NV is processing now as a core. We've got a touch panel. We've also got a laptop which can wirelessly share to this guy here. And then we've also got NL-SB42, so soundbar, NL speakers, NC110, perfect for these kind of smaller rooms. And that's it. You've got your audio, your video, your control system, all contained in this one little box. Okay, so do bear this in mind for these smaller systems. It's really great processor for those kind of rooms. Now you can see here, of course, the local I/O is very different to anything else. Loads of HDMI. You can, of course, de-embed and embed audio on the HDMI, on all the inputs, all the outputs. Now, it's slightly less network audio. So 32 channels total networked audio, QLAN, AES67, and Dante all combined, maximum of 32. It doesn't include any Dante, okay? But you can add 8 or 16 or 32. That's fine. You can do the same number of AECs and microphones as a Core 8 Flex or Core Nano. So the general audio performance is actually about the same. 8 audio players rather than 16, and 1 VoIP line rather than 2. But there we go. NV32, still a super capable Q-SYS core, and it's going to do all your switching and all your control and everything else. So bear that in mind for those smaller spaces. Now, guys, we're going to take another 5-minute break. Then we're going to come back and talk about great big systems, centralized systems with a Core 610, managing a whole building as a single Q-SYS system. All right, let's take 5 minutes, and I'll see you back here to wrap all of this up. Hello again, everybody. I have a question from Jake. Is there a way to set up the NV devices to automatically switch based on whether or not a device is connected? i.e., and this is a very well written question, an NV32 under a desk with 3 different connections, yeah, and an NV21 behind a display. The NV21 then displays whichever position is connected, or would it have to be switched via a control panel? No, Jake, that's really easy to do. Yeah, absolutely. So one of the nice things about these all being native Q-SYS devices is that inside Q-SYS Designer, you have this big block, which is like the NV32 and all of its sources and all of its displays, and the same for the NV21. And for every source, there's like a state that lights up or turns off when that is connected. So it actually monitors the 5-volt connection on the HDMI, or you can monitor when there's actually what we call valid format video coming through. And essentially the easiest way to do what you're talking about is literally you say, you just do it based on the last device that's connected. So you say when a device is connected, and you just draw a little pin, you say, right, from this connected state, and you go over to the NV21 where it's switching, and you say, right, when this device is connected, you go to that source. When this device is connected, you go to that source, and so on. That's the most simple way of doing it. What that doesn't do, of course, is when you disconnect, so say I'm on source 1, I switch to that, I plugged it in, it automatically switches, great. When you unplug it, it's going to stay there, okay, because you haven't said what to do when it goes away. So you can actually do many other things as well. So using the scripting engine, when we talked about the scripting engine being used for third-party control, you can also use it for just controlling, Q-SYS controlling itself, okay? So there's stuff that I've made, the stuff that my colleagues in the UK team have made. On our developer community, if you go to developers.qsc.com, there is a load of people sharing this sort of stuff like, oh, here's a neat little auto switching script that I made. Do you want to use it? And of course, the thing is with auto switching, when you really get down to it, everybody wants it to work in a slightly different way. Okay. That's why we didn't make an official one saying this is the thing, because every customer's like, oh, I want it to do this when this happens, but not when that happens, you know? So you can code it yourself, or you can just get one of the many examples that already exist to do much more elaborate things with auto switching. Same with USB. So we detect the USB connection, and you could do something else in that state. I have a setup in the boardroom here. Sorry, it's a long answer, but I think it's relevant. In the boardroom here in our office, we have it where there's an MTR system, there's a team system, and there's loads of BYOD connections. And basically we set it up that if you're in a Teams call and someone connects their laptop as content to the HDMI, it routes it not to the display, it routes it to the Teams PC's content input, okay? And if you then are not in a Teams call and you connect your laptop, the laptop kind of takes over the room. The laptop then goes up straight to the display, and it becomes the room PC for that time it's connected. So you don't have to do anything on the touch panel, but of course on the touch panel there are also manual switching as well, so that's completely fine. Right, any other questions? Don't think so, other than the one about the network, which we'll get to at this point. Okay, quick drink of tea. Nathan, what if 2 people were to plug in their laptops? Well, Nathan, it's really up to the programmer. So what I have it is that if someone plugs in their laptop, it switches to them. If someone else then plugs in their laptop, it then switches to that person. And then it keeps track of the history. So as you then unplug the last laptop, it goes back to the one that was plugged in before that. And then it goes back to the one that was plugged in before that. And if those are now unplugged, it skips them and goes back further until there's nothing plugged in. However, you might not want that. You might say, well, this connection here is the priority connection. If anyone is plugged in here, it switches to that. Even if people plug in elsewhere, it ignores it unless you manually switch. But if someone's not plugged in here, then all those other ones auto switch in a time-based way. So it is all, I mean, this is the great thing about the scripting engine, is you can code this to work however you want. We don't prescribe how that works. We give you all of the inputs to the control, all of the device connected statuses, and they're always available all the time. And then you can just say, when this happens, drive this switching. Can I control third-party HDMI RX-TX boxes and also using Dante? Yes, you can. So, before we did NV32, there's companies like Visionary Solutions, companies like those who are our technology partners as well, and we do have Q-SYS plugins for those. Absolutely. Wirestorm as well on the sort of, I guess, slightly lower end. There's a Q-SYS plugin to control Wirestorm. And of course, those devices do have Dante, so you can bring that in as well. So that is not a problem. Obviously, the integration is like not completely as fully integrated, but it's very good. Excellent questions. This is good. Right, so let's just save that. And now we're going to talk about much bigger systems and what we need to think about in that situation. That is a very nice cup of tea. So guys, let's have a look at large systems. And in this case, we're talking about centralizing our processing, or maybe not, depending on what we want to do. Also, I want to touch on here this thing, CXQ, okay? Because when you get into much bigger systems, typically you find, again, you need to have amplifiers that are high power that can handle all the different things you might have in a bigger system. So just want to mention that CXQ, just think of it like a much bigger brother to SPAQ. So it's the same basic idea. It's an amplifier. It's also a Q-SYS peripheral. It receives all its audio, all its control, all of that stuff through the network. And this is just a much more powerful, more flexible version of that, okay? So CXQ, it's our most powerful amplifier, and it's also the most configurable amplifier that we do, okay? So you can use this to drive 100-volt lines, 70-volt lines, 8 ohm, 4 ohm, 2 ohm loads, and you can have obviously lots of different power outputs depending on that load. You can also combine channels together, and of course you can bridge channels. That's not that exciting. You can also parallel channels. Now, bridging is doubling the voltage, okay? That's what bridging means. You're doubling the voltage that you can use to drive the loudspeaker. Paralleling is unique to CXQ in the industry, as far as I'm aware. That will allow you to have the same voltage, but double the current capacity. So perfect for 2 ohm loads, 4 ohm loads, subwoofers, things like that. You can mix all this up and have one amp that does all the different speaker loads that you might want to do. And also, because they're Q-SYS peripherals, we get a huge amount of control and monitoring and telemetry data back from the amps all the time without any custom programming, monitoring, the speaker impedance, the voltage, the current, the power going to any speaker at any one time. It's also going to do all of the speaker tuning for you. So this is used a lot in bigger systems. And when we have bigger systems, we typically look to a bigger Q-SYS core, like this one, Core 610. So this would be the next jump up after a Core 110, okay? You can see this is a Dell server. This is one new Dell server because it doesn't have local I/O. It doesn't have, USB bridging on it. We're not putting this next to a Teams PC in a rack somewhere. This is going to be in a server room, most likely in a comms cabinet, just doing all the processing and all of that network traffic. So it is used typically in very large systems like this, okay? You can see there Q-SYS and Dell. So it is Dell standard hardware, but running our operating system. And the nice thing is that like a Core Nano or a Core 8 Flex, you can add a scaling license to this to even take it further. There's really two main ways you might use it. So it could be a single large complex space. Here's an example of like a trade show floor, okay? So here, in a trade show, you have paging, you have background music, you have it doing meeting spaces, auditoriums, things like that. That could all be one great big Core 610 system there. Or you could have it running lots of smaller spaces, so lots of little rooms, and they're all individual, they don't stream between each other, but they are all on one Core 610. You have one Core 610, or maybe a redundant pair managing all of those. Now, if we look at the specifications of this, we can see what it's capable of doing. So here we can see we've got 256 channels of networked audio. All of those can be Dante, okay? You can have 256 Dante channels on this, just like the other cores, 8 included, and then you can say I want 16 or 32 or 64 or 128, 256. So we don't make you just buy the biggest Dante card. You can be very specific about how much Dante you want to purchase. Now, in terms of audio processing, you see it's about 4 times the amount of AEC that you can do with like a Core 110, for example. It's quite a bit more than 4 times all of the other kind of audio that you might want to do. All right. You've got here 14 NMT1s. And again, just like the other cores, you can mix and match those numbers together. 16 audio players, but upgradable to 128 simultaneous audio playbacks off of the 480 gigabyte SSD that it has. Okay, so this is used a lot for themed entertainment. You might have a Q-SYS 10 in the middle of the theme park, sending audio all around the park for little sound effects, background music, music on the rides, all of that kind of thing. And you could have it all playing off of a Q-SYS 10 alongside all these other numbers that it might be doing. And you don't just have a few more VoIP lines, you have 64 VoIP lines. So you could see it could be centralized in a corporate environment with 64 meeting rooms and one VoIP line each for those. If you want to use that, you can do that. Now, when you add the scaling license on, so just like the Core Nano, we can add in a scaling license. We can also add that on here, and basically it gives you, very simply, 50% more network audio and 50% more DSP. So now we've got 384 networked audio channels, and we've got 96 AEC channels, 21 mics. Okay, there we go. Now, let's have a talk about control. So in this situation, you know, with control, we've talked about previously how you have lots of boxes traditionally. You've got the audio processor and the control processor and all of that. And, you know, for one room, that's not ideal, but it does, of course, work. That's not a problem. It can become kind of problematic when you have a whole building done in this way. So here, let's say we've got loads of meeting rooms. Each one have got an audio processor. Each one have got a control processor. Now that's a lot of devices to manage and maintain and upgrade. And when I want to change one of them, you know, I've got to then change all the other ones. It's not going to be a huge amount of fun. So with the Q-SYS 10, not only have we got all this audio processing, but, you know, control for a computer, being honest, is a lot easier than audio, right? You think about audio, it's thousands of samples a second, thousands of packets a second on the network. Everything is super tightly time aligned. Control's not really like that. Even when we think of control as being instant, it's slower than audio, but we don't notice, we don't mind. And that's why we don't really impose a limit on the amount of control you can do, the amount of UCIs, which means that you can have a Q-SYS 10 managing a whole building for control, no trouble at all. Hundreds of control clients, not going to be an issue. And of course, that means you've got one set of scripting engine licenses, UCI deployment licenses, one core. And if you add on multiple rooms in after the install, you want to add some more, you don't have to upgrade the processing, probably. You can just update the program file on it to include the peripherals added in these new rooms. And when you look at the peripherals, you can see there that instead of having the core in each room, here we've got peripherals in each room, but it all comes back to the same network, and that Q-SYS 10 is just hanging around in the background there. So this would be what we would call a centralized deployment. And here are some yellow circles to illustrate a centralized deployment. So here we have, you know, one processor in the middle managing lots of different environments, all hanging off of that same processor. Now, we so far have not been doing this. We've been doing one room or one divisible room, you know, that kind of thing. That would be a distributed setup, okay? Blue circles this time. So here we have a setup here, a setup over here, a core over here, a core over there. And these rooms can all share audio, they can share video, they can share control traffic, but they are independent. They don't rely on the other room's processing. They can just work on their own with a core per area, okay? So this would be a bit of a trade-off here. What one do we want to do? We've got a great big building. Do we want to centralize everything? Do we want to decentralize everything? What can we mix and match a little bit? Okay, so I just wanted to answer those questions now. Centralization does have some benefits, okay? With centralization, we can make changes in one place. We can open up one Q-SYS designer file and the whole building's in there. We can copy and paste from different parts of the designer file. It's all very straightforward in that respect. Now, we also will have, like I said, probably a lower processing cost, because even though the processor is more expensive, we only have one or two if it's a redundant pair. We don't have, you know, however many rooms we've got and a core in each room. Now, we can add redundancy, like I said, really easily. If we want to have a second core backing up a Q-SYS 10, for example, that's super easy to add in, no extra programming needed, really, really easy to do. And we can go to Core Manager. Core Manager is the web GUI on the core. We can go to there and we don't just see, you know, one room, we see a list of every Q-SYS peripheral and its status and every third-party device we're monitoring in one web page. Really neat. But distributed systems have their benefits as well. Firstly, they are modular, right? So all the rooms are independent. Now, this means that I could go into a room and I could update the firmware in there, and I could take the room offline and I could mess around with it, and no other room is going to be bothered by that if the system's been designed sensibly, okay? Now, that's not going to be the case here, right? I've got one processor. If I want to update that processor, there is going to be some amount of downtime as that's happening for the whole thing. Now, that's not necessarily a problem. It just means maybe you need to schedule programming changes, but it's definitely something to think about, and it could be a problem depending on the customer and what they need from it. Now here, even though we haven't got one great big design file, we could make a few template files really easily. So we could have a template, small room, medium room, large room. And then whenever we make a new room, we're almost there. We're almost ready to go straight away. So that's going to save us a bit of time. Core IO, because we're going to have cores in most rooms, the core IO could be used to have fewer peripherals, right? So instead of needing to add QIOs to each room, we could just have a Core 8 Flex. And that means that even though we might have more expensive processors in total, because we have more of them, maybe we have fewer peripherals. Worth thinking about. And we can still use the cloud. We can still use Enterprise Manager to see everything in one place in this type of setup. So even though we don't have one web page locally, we can go to Enterprise Manager and we can see every single system in that space all in one environment. Now, how does this shake up in reality? Well, let's say we're going to do a room or a building now, and we're going to use some of the designs we've looked at earlier. So we remember this one. This was my NV32 example. We've got my encoder, we've got my decoder. Okay. Now I want to have a few of these in my new building. Okay. So we're going to add in 4 of these types of rooms. Okay. There they are. 4 of these rooms. And we're going to manage this with some Core 610s. I'm also going to add in some background music here. So I've got 8 zones of background music. I've got some Dante wall plates there. And now I've got a redundant pair of 610s. And I've got a couple of CXQ amps as well. So the CXQ amps will drive all those BGM spaces. And also I'll put some loudspeakers in these rooms, and they can be centrally powered from the CXQ in this example. But I also have some smaller rooms. Now, earlier I said that this NV32 core mode was a really, really neat little example, right? NV32 here in core mode. And of course we can see that this is nice, this is self-contained, but I do have a core in each room. And I could say, you know, if I was a centralization purist, I could say, well, I can change that NV32 back to a peripheral and use this and have the Core 610 manage these rooms. That's fine. That wouldn't be a bad thing to do. But I actually quite like the fact that this is all neat and self-contained. So I'm going to have 4 of those rooms alongside my 4 executive spaces. And now what we have is a kind of hybrid system, right? Now we've got some elements of this system that are centralized, some that are distributed, and that's fine. That's not a problem. Okay, we can do that. Here you can see I've color coded it. So all of this bit is centralized, and each of these rooms is its own thing. Okay, that's not an issue. So essentially the answer is that there's no right or wrong answer to centralizing or distributing your processing. It really depends on the customer, on the use case of the space, what you want to get out of it, and practically how you want to work in terms of maintenance, monitoring, things like that. Okay, so there we go. Now, as we talk about monitoring and how we can have a distributed system still be monitored centrally, that's where we need to talk about Enterprise Manager. Okay, Enterprise Manager is the cloud-based monitoring and management platform for Q-SYS. Okay, and Q-SYS Reflect is the name that we use for our cloud infrastructure that we have. Enterprise Manager is this service that we're about to talk about, running on Q-SYS Reflect. And essentially, what it takes advantage of is the fact that all of the peripherals in any Q-SYS system and all the third-party devices are always reporting back to that Q-SYS core. So it's very easy for us to take one connection from the core and we get information about the entire system. So here's an example of how this works. Okay, I've got a company here, Fake Hotel LLC, of course, famous hotel chain. And what they have is lots of different Q-SYS systems around the world. So we've got here a few different sites. This is their LA site, maybe this is New York. And in there, they've got a Q-SYS core. Here, they've got a few different Q-SYS cores and a load of peripherals and third-party devices. So the way the information flows is, you know, even without Enterprise Manager, the peripherals flow up to the system, to the core. But now with Enterprise Manager, we can aggregate the information about the systems in a site. So we could look at this site as a collective entity. And then we can also put all of the sites into a single organization. So I can look top down to see all my sites and get a summary of their status, and then drill down into the others from anywhere in the world. Okay, so of course, this means that we can do preventative maintenance. We can then get into this dashboard and see everything. We can actually make changes here. We can go in and look at user interfaces. We can change network settings. We can do a whole bunch of different things in there. And of course, we can do preventative maintenance. We can deploy support. We can also do remote assistance, because it turns out a huge number of AV problems can be fixed remotely. But typically this involves, TeamViewer and VPNs and all these other things, someone on site with a PC. We don't need any of that with this. We can just connect to the core through the cloud. Actually, we can open up Q-SYS Designer and we can start to mess with the system, change things, improve things from anywhere. So here's a little video about how this is actually set up, okay? Because typically these things sound great, but they're really hard to actually set up. So here we've got a system. And what I want to do is put this onto Enterprise Manager. So now I'm on site, I'm connected to the core locally. This is Core Manager. And what I'm going to do is register this core by just hitting Start Registration. Assuming the core has internet access, of course. Then what I'm going to do is get a little 6-digit code there. I'm just going to copy that. Now, what I can do is log into my Q-SYS Reflect Enterprise Manager account. And I can just log in with my QSC ID. And here you can see I've got lots of sites. I can add a new site at this point, or I can go to an existing site. And all I need to do is just hit Add Core, put in that code, and that's it. Now that core is going to be added to this site. And not only that core, but via the core's connection, we are also going to get all of the Q-SYS peripherals as well. So now you can see we go down to the inventory. We can see there we've got statuses for every peripheral, whether it's a third-party device or a native Q-SYS device. Okay, the third-party device is obviously being monitored with our technology partnership program. So there we go. Enterprise Manager is going to be a huge benefit to all sorts of different Q-SYS installations around the world. So professional tier, that's what we've been talking about. That's going to let you have a UCI for control and support. It's also going to let you connect via Designer to just do everything you can do in Q-SYS from anywhere to any system around the world. Do check that out. That's at qsys.com/reflect, and you can get a trial if you are an end user to use with your existing Q-SYS systems if you would like to do that. Now, we also mentioned a bit about redundancy in the last few sections, okay? Just wanted to point out how that actually works. Because with redundancy, you can have any level of redundancy. You could have 2 of everything if you want to. With Q-SYS, we can quite easily add core redundancy and also network redundancy. Now, this is what we've been doing so far, right? Cores, networks, peripherals. And of course, if the core were to go offline for any reason, these peripherals now aren't really going to know what they should be doing. They haven't got anywhere to send their data to. So you've got a big problem. Now, it's very easy for us to add a secondary core. All we need to do is make sure that core has the same licenses, the same software upgrades as the primary core. And then when you actually push out the config, it sends it to both of them at the same time. They synchronize together. And then what happens is one of them goes into standby and it just monitors the other one. Okay. Now, if this one were to go offline, after a second or two, this one will spring into action. It will then tell all the peripherals that it is now in charge, and the whole failover process takes a few seconds. Okay. Longer if you have Dante, a little bit longer, you have to wait for the Dante to also synchronize, but still a very short amount of time before everything is up and running again. All right. So that's core redundancy. Now, the thing is, what about if the network has a problem? Okay, so this network could be, it could be a super fault tolerant end user network with spanning tree and all the rest of it, and we're not worried about the network. Or it could just be one switch, right? It depends on the kind of system that we're talking about. And if it's one switch, it doesn't matter that we've got 2 cores. If that switch goes offline, everything stops working. So we can also add a secondary network. This is the LAN A, LAN B thing that we have on the core. Okay, through this we can do QLAN primary, QLAN secondary, Dante primary, Dante secondary as well. And now you see that we've got 2 connections to every core. Some of the peripherals support redundant networking, some of them do not, okay, just so you're aware. And then we can lose a core and we can lose a network, and everything just keeps on working, which is really, really great. So we can add that in just as easily. Now, talking about networks, we did have a question earlier. Should we have a dedicated Q-SYS network rather than, using a client network, for example? Well, QLAN itself technically can work on any gigabit network. Okay, it's standard IEEE protocol, so it works on layer 2 networks. It even works on layer 3 networks. It's all routable as well if you want to get into that. And it can work on a converged network, which means sharing with other traffic, or a dedicated network. It really comes down to the client you're working for and the capabilities of the integrator, really. So some clients say, absolutely not, none of that AV over IP stuff on my network, thank you very much. Then you would put in a dedicated AV network, and that could be very small, or it could be quite a big thing. And if you're the integrator, then you would need to configure the network according to our guidelines, and that has quality of service, IGMP, a few other things that you need to do. The same thing for if it's on a client network. We would need the client to implement quality of service and IGMP that works properly as well. Okay, now that's all well and good. However, it might be the case that the integrator doesn't really want to be on the hook for the network working properly. Okay, maybe they're just not super comfortable configuring switches, or maybe they're not comfortable with the support they're getting from their switch provider, for example. So for that reason, we do actually we do work with Netgear on this range of products, NS, right? These are pre-configured network switches designed for Q-SYS, but actually designed for all sorts of other AV over IP traffic as well. Now, if you haven't noticed, Netgear have been really good. Netgear have made some fantastic AV switching hardware. They already have their own configuration profiles on there for different types of AV traffic. However, we've been making switch configs for Q-SYS for quite a while, right? Probably about 15 years, something like that, longer than a lot of other AV manufacturers. And we've made a configuration which runs on this Netgear hardware, which allows you to do Q-SYS audio, AES67, Dante, Q-SYS video, control, third-party devices, all just plugged in, plug and play. You don't have to worry about the switch. You can just connect them up. If you have multiple switches, then all you really need to do is give them unique IP addresses. You don't need to change the configuration. So this is designed for small to medium dedicated AV network deployments. And the cool thing is that if it doesn't work for any reason, you can just call up Q-SYS support. Okay, this is a supported Q-SYS product like any other Q-SYS product. And Netgear also have a good support team of their own. Other switch manufacturers, your mileage may vary when you call up and ask them very specific questions about AV deployment. The other nice thing about this is the power that it can supply. So for NV series, we do need PoE++. This can provide, depending on the model you choose, up to 90 watts of power on every single port if you want. So great for NV32 and also for NV21 as well, even though that's a lower power requirement. All right. Also good for NL speakers, where you might have lots of NL speakers all in PoE+ mode. That's about 30 watts of power per speaker. They also have rear-facing ports, which is just really nice. They look good in a rack because the ports are facing backwards, so you can easily see what's connected to what. Now, from us, the selection is essentially, do you want 26 ports or 10? And do you want PoE++ or PoE+? And there you go, that's the NS switch range. But just to reiterate, this is not a requirement for Q-SYS. You can use any decent gigabit network, but you must configure it correctly according to the guidelines in the Q-SYS online help file. Now, I did have a question here from Andre, just going back to Enterprise Manager really quickly. So Andre says, if you're an installer that does maintenance for several customers, how does that work with Enterprise Manager? That is a great question, Andre, because of course we have companies that are called, well, we call them managed service provider, MSP, where it's an integrator who is providing support to lots of different customers. Now, if you're an MSP, you can sell Enterprise Manager in the same way you would sell any other Q-SYS product. And what happens then is your end user is the organization owner. So Fake Hotel, they're in charge of the organization. They can see all of this stuff. That's all well and good. However, they can invite you per site. They can say site by site if they want to invite you to be a viewer only, or they can let you have read and write access to an entire site. Or if they're really, in a good mood, they can invite you to be an organization owner of the whole organization alongside them. And then you can actually see, read and write to everything. And of course, this is just a question of what the end user is comfortable with. They're always in control of it, but they can invite you as the service provider. So then what you see in your dashboard, you see a list of all the organizations that you're invited to when you log in. So you go in, you say, right, I need to look at this customer today. You open it up, you see all of their sites. You open up the sites, you see all the systems. So absolutely, it is designed with that in mind. If you contact your local Q-SYS rep, you will be able to talk about becoming a managed service provider, and then you can actually instigate all of this rather than getting it sort of secondhand from the end user, if you like. Cool, so we've done the question about the dedicated network as well. If there's any other questions on that topic, feel free to put them in the Q&A. And now, everybody, we are pretty close to the end of the training. Okay, so one last thing I want to just mention, going back to licensing, we've talked about a number of features, a number of products that are a software add-on. And what I wanted to do was just put that all in one place, just so you can be really clear about what's a software add-on and what isn't. Okay. So like I said, we've removed a lot of bits of hardware, made them software, made them lower cost, made them more available. So here we have a little summary of this. First kind of category of licenses is the core scaling license. And what this means is you're not adding new features, you're just taking things the core already does, and you're allowing it to do a lot more of that. So these are available on the Core Nano, the Core 8 Flex, the Core 610. So you don't need to go up to a much bigger core where you might not use half of what it can do. You can just, via software, go sort of halfway. Then you've got core feature licenses. So these are features you're adding into the core. The scripting engine, that's all of the third-party device control and all the scripting and plugins and actually Q-SYS controlling itself, like we talked about with advanced auto switching. Then you've got the UCI deployment, unlimited UCI deployment to any number of clients. That being, like I said, web browsers, Windows PCs, iOS viewers, Q-SYS touch panels, MTRs, Zoom, Google Meet, and also Dante. So this would be a feature that is included with most of the Q-SYS cores, 8 channels, but you can add more than that up to the core's limit on software-based Dante. Okay, so that's core feature licenses. And then you have peripheral feature licenses. We're adding features to peripherals that many people might not want to use, and some people do want to use, which for now is the AV bridging feature license. Okay, so AV bridging, like we said, that is an optional feature for the TSC series and also for NV21, whereas these products will be used quite often without that. So instead of making everybody pay for that, it's just an optional feature should you need it. I do have a little question here from Nathan. Is the lecture capture Panopto compatible? So Panopto, I assume you're talking about local capture on a PC. So yes, so the USB bridging that we do, where we're feeding cameras and we're feeding audio, things like that, through that USB connection, that is not restricted to any particular software. It's certified for a lot of conferencing software, but it's actually totally driverless, it's totally open. So that works with any software that supports standard USB audio and video. So yeah, that would be Panopto. It even works with things like Android tablets and like iPads. You can just plug in and you get bridging on those as well. So we do not restrict the interoperability of USB bridging. Okay, now one last little topic and then it's exam time, guys. So all I wanted to do was just touch on the Core 5200. So we don't see these every day because they are reserved for the largest, most complex systems. Here it is, Core 5200. For the very biggest systems, it might be a football stadium, it might be a whole building like this, it might be a hotel, it might be an airport. The key thing you need to know is it's very, very powerful. And here's the Core 610 design that we did earlier. So I just thought, just to give you an idea of the scale, copied and pasted that a bit. There you go. So you could do that on a Core 5200, probably. Now, the limitations of this are 512 inputs and outputs on the network. All of those can be Dante if you want. That actually makes it the highest channel count Dante processor in the world. Then you've got 160 AUC channels. you've got 28 NMT1s, or of course, some kind of combination of the two. And then the same as the 610 for audio players and VoIP, up to 128 audio players, up to 64 VoIP lines. All right, there's the Core 5200. I'm just going to get out of the way here just so you can screenshot that if you want to. Of course, this is also on our website. So if you just search Q-SYS cores, there's a processing page where it compares all of them in actually a bit more detail than this. So guys, that's been Q-SYS Architect training. Hopefully you've seen the benefits of Q-SYS. Of course, really simple to design, simple to integrate. It's all software based as much as possible to make installation really, really easy. You've got, of course, real-time system-wide monitoring built in with Q-SYS peripherals, with third-party devices. It's a single platform rather than lots of things kind of cobbled together. So single point of contact for consultancy, for training, for service on the whole platform, audio, video, control. And as you've seen, it's very, very scalable. So as we scale up, we don't need to rethink our approach. We don't need to use some different product range. We just go bigger and need to think about limitations where it makes sense. Okay, so that's been Q-SYS Architect training, but don't go anywhere because you're not certified yet. You've got to do the exam. Okay, it's going to be fine. Don't stress. Now, to get to the exam, guys, you are going to need to go to training.qsys.com. Now, you're going to see a link later on this morning with a link that says click here to take the final assessment. All I need to do is press a button that says that you all actually showed up to the webinar, and then you will be able to do that. Okay, so do go to your training dashboard. I'm going to now tick the thing that says you're all here, and in a few minutes you'll be able to take the assessment. All right, now thank you very much. I've been James Martin from Q-SYS UK. You've been a great class, and I hope to see you in the future, maybe on another training course. Have a good day. Thanks.